Hi everyone, welcome back. This is Raju from Smart AI Technologies. Today we are going to see a project called Subject to Answer Evolution using Deep Learning and NLP. In this project, the main purpose is to evaluate the answer given by the person with the real answer. How much percent properly gave the answer. Based on that, the marks will be provided. So it is an automation of the evaluation of the answer by the person. Now, we'll discuss first the demo, how it is working. Next, we'll discuss about the base papers that we are referring, and the most important thing is what is our uniqueness regarding implementation rather than the present works. Maybe few papers which are already working on this, they already presented few things. So what extra we are doing, that is proposed system and existing system, both we need to see, and we need to prove that whatever methodology that we are trying to follow is the best and it is giving a good result. So before moving further, we'll try to test our app or the application which we built by giving some inputs. So here I am giving two sentences, so I can get the score, how much percentage they are similar. And you should remember one thing, this is not based directly on how many keywords are matching, how many same words are there. No, it doesn't directly go like that. If you want to do like this, there are some simple techniques like similarity scores done with the help of some libraries, how much similar they are. Some libraries count the alphabet, some counts the words, like that. There are some already available libraries, but that they are not good in every condition. That's why we are building our own deep learning based model which can calculate us how much similar the answer given by you and as well as the original answer, how much percentage it is same. So we will implement it on few more sentences. Then we'll go on discuss about the IEEE papers and existing system, proposed system. Technically, we'll speak what exactly we are planning to do and what we already implemented here. And we'll see some IEEE papers and we'll see their methodologies. We'll define our own methodologies and we'll implement that. And then finally, I'm going to show you how it is working. Whatever code I'm doing here, how complete application is done. So we'll discuss again about this. So I'm going to fill few more sentences for verification. Some sen- So they are most similar. So we are getting around 90%. They are similar. And we'll try few more sentences which are not same, which are having very less similarity. So same sentence, but change second sentence will be different. So now we can expect the score will be very low because both sentences are literally very different. It's around 0.3 percentage, less than 1% it is. That's what. So we tested it on used dataset. We trained a deep learning model, and before training that, we applied NLP, and then for feature extraction also we used one of the deep learning model. So there's a lot of process involved in this before getting the good result. And yeah, so the whatever results you are getting here, the accuracy will be more than 90 to 95%. And again, when you approach us, we will be giving you the whole code from dataset to the complete web application, whatever you are seeing here. So it includes complete Python codes, complete HTML and CSS codes, as well as with that, we help you to implement this in your system completely, and then we will help you with the documentation part. A documentation for introduction, abstract, methodology, existing system, proposed system, literature survey, references. These things will be given to you completely. And if you have any presentations, if you got any doubts in future while when you take the project, we will be almost available for you for any discussions, further discussion, or any improvements. You can discuss with us. We can set up classes. And we can try few more sentences. Hmm. You see, it's even less than 0.1%. So that's what. So based on the results, you will get the things accuracy or not accuracy. You can say how much similar. There is a percentage of similar between the answer that you give, the answer it is actually is there. You can add any sentences maybe related to your theoretical history. Maybe if you take history sentences you can add, or if you take any English thing, you can add the English lesson answers and you can check. Not only the sentences that I am trying to add from the database, you can add it from external sources also for testing. You see, I'll add one physics sentence. So let us check this sentence whether they are similar or not. You cannot like this any subject or any data you have in English. So you see here, you are getting good result. Same thing happens. You can add from English, you can add it from history, you can add it from anywhere. You can test it. We already used a data set which is having so many rows. You can even extend that data set. If you are doing a research over this, you can add few more rows of data there. Sentence 1, sentence 2. You can add and you can train the model to the very high level thing. For example, let us say you are preparing it only for history related. So then make a data set for history data, and then train our model. You will get 100% accurate results for any history answers. Especially that means when you take a target for one subject and you train the model, there will always be a chance of getting good result, because we are having general question and answers. So if you are going to any targeted, you can make your own custom data set and you can move with that thing. So like this, you can test it for any amount of data, you'll be getting the results. Now we're going to see few IEEE papers and what they are trying to mention, and then we are going to define our own proposed methodology, and then I'm going to show you the code snapshots, okay, how we are coding and what we are doing for feature extraction and what we are doing for training the model, and how our methodology is better than the present existing systems. So all these things we'll discuss now. The base paper that we are selecting for this work is subject to answer evaluation using machine learning and natural language processing. So first we'll try to understand what this paper is proposing, what methods or methodologies they are using, maybe for pre-processing, maybe for feature extraction, maybe for model building. One by one we'll understand these things, then we'll even see few more papers as a references what they are doing. Once that is done, we'll try to propose our model and what we are trying to add, what we are doing extra, and how our work is better than the proposed methodology. So we'll define these things one by one. So as we can see in the abstract, this paper proposes a novel approach, okay, using machine learning. When it comes to model building, they are going with machine learning. Here only the lot of difference is there between this paper and our work, because we are concentrating on deep learning model, and then they are using natural language processing techniques such as WordNet and Word2Vec. These are things which comes under pre-processing, you can say. And then there are two more things for feature extraction. That is, word movers distance is one of the feature, and cosine similarity is the another uh, feature. For any given data, they will try to extract these two things, and the model they are concentrating to go with is multinomial naive Bayes MNB. So here the things are very clear. For handling the data, that is for pre-processing, they are using techniques like WordNet and Word2Vec, and few more they are using. We'll see that in complete paper, that is here they are mentioning it clearly what they done. Okay, we can see that here. First thing, they are using tokenizing nothing but converting your data or text data into numerical data, you can remember like this, or mapping your text data to numbers. It is a needed process, needed technique. And then stopword removal, again this is a normal pre-processing technique. And part of speech tagging, again on the stop words removal, we will be removing the stop words just which are like in, on, is, the, and like there are 32, I think there are a set of words 32 to 34, so which we call them as stop words, which doesn't carry much meaning of the sentence. So we'll try to remove them. And part of speech tagging is also done. And then lemmatization and stemming will be there. So under lemmatization, for example, you say if I am going to school, and there is another word like I will go to school. So here when there is a variation of that word going in the data set, actually they will try to imitate the same meaning. But if you are having more going something like that, the different words, during the mapping it will cause a problem, because same words you are mapping to two different values, so that will become a problem. So that's why we try to convert them, lemmatize them into only one type. If it is a going, it will become a go anywhere. If it is a go, it will stay go. And went also will become again a go. Okay, and that is a limitation. Again the stemming, when it comes to stemming, here it will try to understand the meaning. For example, if there is a word I am going to school, if there is a word I am moving towards the school, move, go, they are having a similar, almost similar meaning, so then it will give us similar word. Even move will be made as a go, but in lemmatization similar word with extra. Okay, maybe feature terms are like that, they will be taken back to the initial word, but here different word with the same meaning will be grouped as in a single word. So like this, these are all minimal required pre-processing techniques in NLP. They are doing it. And bag of words, the most important words we collect together. Okay, we combine together the most important features, words, keywords. So set of them we call it as a bag of words. And IDF and DFs are calculated. This is document frequency. That means here a document frequency nothing but the words, keywords, repeated keywords. All these things are there. And mainly the last things that are needed, word to wake and Jacquard similarity. Jacquard similarities, again one of the way to calculate the similarity score. To show you, I added a code. Okay, even when you approach us, even I will write some code for this, and I will show you that how it works. How these people, whatever coded, na, how they are using it. But how our work is better than that with code. I already done the course. Even I will show if you want to just showcase you Jacquard similarity score, how it is being calculated. It's the simplest way. They are almost trying to go with the simplest way to extract the features from the stuff. And word movers distance is another way of extracting the another feature. But here the problem with this, we need to understand what is the problem. Even this paper is again trying to mention the problem also. If you study carefully, what's the drawback of using this? They will not try to understand almost the meaning, complete meaning are like that. These are all keyword based. They'll try to concentrate on keywords, but when you are working on answer evaluation and there you go with only keyword, will not be that much good move. There's a drawback. Even this paper is presenting that drawback somewhere. Okay, that's a challenge. Okay, that's a challenge. Normally people will face when they will go with like these feature extractions. So here now what actually the drawback of this entire paper, which these people are made, is that they are trying to extract the feature from the given text, and mainly those features, all of them are keyword based, and they will not try to understand the context, what is their meaning, you can say in normal word. So they will not try to understand the meaning to that much depth, and only keyword will be taken, and what it doesn't feel as a keyword, it will remove it. And in the process you already removed so many words, stop words are okay, so many words are being removed. And when you apply some stemming and lemmatization, especially in question and answer, if it is a different NLP project, doing the stemming and lemmatization is good, but especially when it comes to question and answer evaluation, doing stemming and lemmatization sometimes will become a problem. Because if I say I'm going to school, and let us say there is a question, where Arun is going now, or where is Arun going or moving towards. So the answer, if the answer is Arun went school, Arun going school, Arun go to school, so all of them try to give different answer. But when you do stemming and lemmatization, it doesn't matter, it will take into the same criteria, because all the words will become a go go go. There is no meaning, you will lose the meaning in the process. So there are so many challenges in this paper. So to overcome this, what we do is, first we'll take the set of those words whatever we get, and then instead of extracting the normal features, similarity score or like that, we'll use a deep learning model here, BART model. We'll use BART model, and we'll extract the feature. So this feature extraction will be like, it will take the entire sentence, it will convert them into numerical values or tokenizing, what you say. Once it comes, it will try to extract the feature out of that. Just these deep learning models, feature extraction nothing but, you should remember that they will be pushing this multidimensional array to the layers. Those layers will try to do the reduction of the dimension. So once they will do, finally we'll be getting very much reduced dimension of the data. That, for example, let us say the original thing is 300 cross 300 multidimensional array. So when you pass it through the deep learning, it will become 2 cross 1, 3 cross 1, like that. So all this deep learning's main purpose is to do the dimensional reduction. That's what we say features. So finally the whole data will be considered, so we don't lose anything, we don't change anything, but that will be converted into some low dimensional data. So then it will be used to train another model, another BART model, where we train specially to check where the similarities, class 1 or class 2, class 3 similarity, which it belongs to, how much it belongs to, like that. Okay? So whether they are positively similar or negatively similar, or they are neutral, like that we do normally. So we are going to do that using another BART model. So here we can expect during future extraction we are not disturbing the original data, so we can expect there is no loss of the meaning in the sentences answers. So if there are minimal change in the meaning in the sentences during the checking or testing, it will affect. So it can be handled by the our defined methodology very easily. Whereas the proposed paper, whatever the existing paper, sorry, whatever the existing paper is there, they will be facing this problem. This is our proposed methodology. We'll be almost using deep learning models, mainly BART models, and we can check with any other paper. Evolution of subject to answer using machine learning. Again, these people are going with almost similar approaches. They are going with NLP plus ML, ML and NLP. They are going, and again, even these people are going with lemmatizing, word netting, or bag of words. Almost people will try to approach the problem in the same way if they are going with ML, because there are so many limitations when you go with ML. You need to extract features. So if you need to extract features, you need to do these things compulsorily. But in our case, we have much freedom, and there is a more space to get a good results. And you can see this paper also. Even this paper is talking about machine learning and NLP. Again, you can, they are also doing the same again, almost the same thing, but in this case they are building a application just like us, web application with a Django. This is one case, but now we'll come back to our project, a web application. So here you can add any sentences and you can test, but how it is built. So we used HTML and CSS for the front end, and we used Flask in the back end, and then we integrated whatever model we trained. So here you see this code is to train the model. Okay, this code is to train and save the model and use it. So here we are training that model, BART model. And you should remember one thing, these models are very complex models, and you need to train it for long and long epoch. Actually I trained my model for only one epoch. It took around 1 hour or like that, but you need to train it for more epochs. So when we give the code to you, I'll be telling you how many epochs you can able to do it. You need to train that much. For example, you can train around okay, this accuracy will be increasing, and you need to train it around 10 epochs minimum, because it will take lot and lot of time, hours together. So even you can, if you increase the batch size, there is a possibility of getting better accuracy, but the problem is that you need to train for more hours. Again, the time is the thing. If you have good GPU with you, it will be lot better. If you have a good GPU, you can train it for long epoch and you can get more accurate results around 95, 96. If you have good GPU, if you can train for more epochs like 20 epochs, 30 epochs, uh, so that is the thing. So this is the code that we do, and we save the model here, and whatever the model trained model.h5 we save, that model only will be using in our front end. So whatever the code we are doing, so these are the codes that we done for the front end part. So you can see here we are using that saved model. We trained and we saved that model there. So now I'm loading that model. You can see that here I'm going to load that model, train model. So to this, whenever I feed two sentences, I'll be getting results. How much accurately it is trying to give the proper result. It means two sentences are there. Then how much similarity between them is there contextually, not only keywords are like that. Because we are using deep learning, we are taking the entire sentence as a feature. We are not removing anything, so we don't want to lose the meaning. So the whole thing will be took as a data and processed, feature extracted and predicted. That's why we are getting good result. So in our case, the main thing is app.py, the server side coding, which is handling all these transaction, whatever things are happening, exchange of the data are happening. Okay, these are all HTML codes. So everything will be given to you. If you approach us, we will be giving the whole code. We'll be helping you to train this. We'll be helping you to test this. We'll be helping you to run the entire application in your system. Okay, and one more thing is we charge accordingly. We normally don't charge very high, which is in the market. So we'll be charging according to the requirement. If you have any further idea of improvement, maybe let us take an example where you want to make like an app where there will be a question, there will be a gap below the question, there will be another question, there will be a gap below the question, where you need to type a answer, and you want to submit 20 questions at once, and I need to calculate for each answer, for each question, that answer will be evaluated for each question and marks will be allotted. Just like that application, if you want to do it, that's the improvement of what we already done. Even I will try to update like that application in few days. So if you want like these ideas, if you have like these ideas to improve over that existing system, you can come up with an idea to us. We will implement that customized requirement and we will be giving it to you. And if you have any questions or any doubts or any requirements, you can contact to us to the given number below, and you can WhatsApp us. It includes even WhatsApp. You can just WhatsApp us and we'll be replying back with answers. You can contact us for your code or inquiries or for anything else regarding this project. And also we Smart AI Technologies provide machine learning, deep learning, AI related projects, so many projects, and also final year project support for BE students, BTech students, MTech students, as well as if you are a PhD people, and if you are doing a research and if you want any technical support, you can approach us. So yeah, that's all about today, and we'll be coming up with some good projects in the next session. Thank you very much.